Hello, everyone. You are back again to our math journey. And in this journey, our goal is to make math enjoyable. Welcome back. And I hope each and every of you is doing great. If you haven't subscribed yet to our channel, do not hesitate to subscribe to our channel, like the video, and share it to as many people as possible. Today, we are going to look at linear equations. We're going to look at linear equations. Now, where are we coming from with linear equation? Remember the last time we discussed equations, and equations, we said that equations can be put into two categories. Linear equations, we have linear equations, and then we also have what we call polynomials, a polynomial. So with a polynomial, we can break that down into what we call a quadratic equation. It can be a quadratic equation, it can be a cubic equation, and many more, and many more, and many more. So that's where we are coming from with linear equations. Now, linear equations was propounded. It was propounded by a man named Sir, a man named Sir William Rowan Hamilton, Sir William Rowan Hamilton, Hamilton, in the year 1843. In the year 1843. But today we are just going to focus on linear equations, and then we will continue from there. Now, we know that an equation. Last time we said that an equation is a mathematical expression. So an equation is a mathematical expression. Is a mathematical expression that contains an equality sign. So if you have a mathematical expression that does not have an equality sign, it will be called an expression. So, for example, if there's an equation, an equality sign in a linear expression, then, so for example, we can have a linear expression. The moment you have an equal to sign in it, it becomes a linear equation. We can also have what we call a quadratic expression. A quadratic expression. That means that it doesn't have an equal to sign in it. But the moment an equal to sign comes in, it's now referred to as a quadratic equation. We'll get there, but we are just trying to look at the difference between expressions and equations. So for sure, an equation is where you're going to find an equal to sign in a mathematical expression. Now, how do we know? How do we know? How can we be able to tell? What are the signs to tell that this thing is a linear equation? How do we know? We will know shortly. We'll know shortly. So let's imagine that we said that they have the form y equals to mx plus c, or sometimes it can be of the form, y is equal to a plus bx, or it can be of the form, or it can be of the form. Some books will write it as y is equal to ax plus b. They're the same thing. It's the same thing. Okay. So there's supposed to be an equality sign in there. An equality sign in there. That's a form. Now we know that the y here is usually called the y here. This one here is usually called the dependent variable. Dependent variable. What does it mean? All these two depend on the y. That's why it's called a dependent variable. It's called a dependent variable. So anytime you see an expression with equal to sign with in the form y equals to mx plus c, that tells you clearly that it's a linear equation. You can see that the degree here is 1, right? Like y is equal to mx to the power 1 plus c. This, because this side is 1, which is the same as mx plus c, that tells you it's a linear equation. It's a linear equation. So the coefficient of x, which is m, the coefficient of x, this one here, is the what? Is called the coefficient of x. Where's the x? This one here. That means that it is attached to the x. And another name we give to that, is called the gradient. The m there is called the gradient, or what we call the slope. It's called the gradient or the slope. Now we can also say that this dependent variable, the y, is also known as the explained. It's called an explained variable or variable. Explained variable, and that's the effect. It's also known as the effect variable. It's also known as the effect variable. So those are the names given to them. Now we're going to look at this one here, the x, right here. This x is known as the independent variable. It's an independent variable that relies on the y. The x is an independent variable that relies on the y, and it's also known as the explanatory variable. It is able to explain what happens to y. So the explanatory variable. That's why that one is called explanatory, and then this one is called explained. So the x helps us to be able to explain y. Explanatory variable, and it's also known as the cause. So x causes y. X causes y. X causes y. So y becomes the what? The effect. Now we also have, finally, we also have this one, the c. The c here is also known as, the c here is known as the constant coefficient. The constant, sorry, known as the constant coefficient. The constant coefficient. Constant coefficient, or just a constant. It can also mean just a what? A constant. Or it can also mean y-intercept. The y-intercept. What the y-intercept? The y-intercept. The y-intercept means when x is what? When you have x being, when x is 0, when we put 0, when we put, let's say y is equal to mx plus c. If we put 0 here, it's going to give us 0 plus c. So y gives us c. So the c there is the y-intercept when x is 0. That means x is 0, you have the y. So when you say y-intercept, we mean when x is equal to 0. So far, I hope we've been able to identify the things concerned. So we know y is the explained variable, or the dependent variable, or the effect variable. And we also know that the a, so let me write that. We're saying that the y is the dependent variable, explained variable, or effect variable. The a here we know is a coefficient of x, because it's attached to x. So it's called the coefficient of x. And then we know that this x here is known as the independent variable. Also remember that the a, which is coefficient of x, is also known as the gradient or the slope. And then the x here is known as the explanatory variable, or the independent variable, the cause variable. Then the b here, we said the b here is known as the y-intercept, or the constant coefficient. It doesn't have any x thing attached to it, so it's called the constant coefficient. So now let's look quickly at something like this. We have, don't forget, we said we have y is equal to a plus, let me use a different color. Let me take maybe yellow. We say that we have y is equal to a plus bx, and we are saying that the y here is the what effect variable, the dependent variable, and then we have in the a here. The a here is the constant coefficient or the y-intercept when x is 0, and then we have this b here. This b here is the coefficient of x because it has x attached to it, and then the x here is basically the x there is basically the independent variable or the gradient or the slope. So we are going to be able to look at certain things. How are we able to solve an a linear equation? First, we need to have what we call the value for the b. This b here. How do we arrive at the b? So b, which is our gradient, don't forget, or our slope. We're saying that that b is usually what? A change in y over a change in x, or what we call an increase in y divided by an increase in x. And we can rewrite this as y2 minus y1 divided by x2 minus x1. So first we have to find the slope. To be able to find a linear equation, we find the slope or the gradient first. Once we find the gradient, we plug it in. So let's say that we work. I'm just using examples here. We'll take a real example. Let's say that we work out the b and we're able to get b to be, let's say, 2. That means our y from here, right? Our y is going to be what? A plus the b. The b is 2x. How are we going to get this thing here? We have to say when x is 0. All right. When x is 0, when x is 0, let's take this. Let's say when x is 0, you put in 0, right? We're going to get y is equal to a plus 2 into 0. And then we are going to get what? Y is equal to a. So now we get a and we come and plug in. Once we plug in, we're going to have something like this. Y equals the a that we got, maybe a value that we don't know. Maybe we got maybe negative 2 plus 2x. And then there we have it. So that's how we work for a linear equation. That's how come we are able to derive a linear equation. So let's take some examples quickly. Let's have some maybe examples quickly. Let's say we are still on linear equations. We're still on linear equations. All right. Let's imagine that we have 2 points. So let's draw something like, maybe let's draw. We know this is our what? Our y-axis. Okay. And we know this is our x-axis. Okay. Let's imagine that there's a point here. Let's imagine that we have a point here. And we also have a point there. Okay. We have a point here, we have a point there. So let's imagine that this point here is 1, 1. Because this side, let's imagine this is 1. And let's imagine that here is also positive. Remember, this is a positive side. This is our positive side. This is our negative side. And that's also our negative side. This is also x-axis, but the negative side. This is also y-axis, but the negative side. And this x-axis is the positive side. So this place is 1, and that side is also 1. So that means this point here is x. Remember, it is x comma y. So this is 1 comma 1, like this. Now this point here, we have it on the negative side, right? So let's also imagine that this right here is also, let's say here, there's negative 1, and then let's say here is also negative 1. That's how come they're able to meet. They meet here. So we have this point also being negative 1 comma negative 1, like this. And then we can be able to put a line between it. We can be able to put a line like this. A line between it. So we're having something like this. So we have a line. How do we form the equation? What is the equation? They can ask us that. What is the equation? What is the equation of this line? What's the equation of this line? How do we able to arrive it? What's the equation of the line? How do we get a line? The line is of the form, 1 comma 1 and negative 1 comma negative 1. How are we going to solve this particular problem? So we have to have this as point what? We have to have this as point A. You can say that this is point A. Let's say this is point A. And then let's say this is point what? B. Okay. So don't forget our point A is here, right there, which is 1 comma 1, and our point B is also right here, which is negative 1 comma 1, negative 1. Now we said that for every line, right, equation of the line, we said it's of the form y is equal to a plus bx. Don't forget that. And we said that we have to find the first thing we do is to find the slope or the gradient or the constant or the coefficient of x. We have to find the what? We have to find the b, which is what? The gradient or the slope or what? The coefficient of x. Don't forget that. That's the coefficient of x. So therefore, we know that our b, we said that it is what? The change in y over change in x, which is the same as, we said it's the same as what? An increase in y over what? An increase in x. And we said that's the same as what? It is the same as y2 minus y1 divided by x2 minus x1. So how do we know which one is our y2 and x1? Since this is our point A, we know this is point A and this is point B. It means this is our x1 and this is also our y1. This is also going to be our x2 and this is going to be our y2 because we have point A and point B. So in the formula, we're going to have B to be equal to y2. What is our y2? Our y2 is negative 1. It's right here. Our y2 is this number here. That's our y2. It's negative 1. Now look at this sign. We have to bring that sign negative. What is our y1? Our y1 is here. It's 1. It's not negative 1. It's just 1. So we put 1 there. And then we divide the whole thing by x2. What's our x2? Our x2 is negative 1. We put negative 1 there. And what is our x1? Our x1 is 1. So I bring the sign first, so minus 1. What are we going to get? We are going to get negative 1 minus 1 is negative 2. How do we know that? We are owing, don't forget, you are owing $1. You are owing $1. Why are we owing? Because the sign is negative. You are also owing another $1. You didn't pay any of them. So it means you are owing 2. That's why it's negative 2. That's why it's negative 2. And we divide that by also negative 2. And then we are going to get what? Negative 2 and negative 2, which is 2 cancels out. And then you're going to get negative 1 over negative 1. The negative cancels out to be positive, and you have 1 over 1, which is what? 1. So our B there is what? Is 1. Now, we need to look for the A. How do we look for A? To look for A, we can say that to look for the A, we say when X is what? When X is 0. So if when X is 0, we're going to get Y is equal to what? The A, either Y is equal to A plus B, right? Plus B plus 0. So we're going to get Y is equal to what? Or what we can do is that we can pick any of the values of, I think we should take it back a little bit, and let's take a breathe in, breathe in. So we can pick any of the point, this one. We can either pick this one or pick that one. Let's say we are picking point A. Pick point A and plug it in the equation, point A. So we're going to have Y is equal to A plus, right now our B is 1. So 1x, right? Which is Y is equal to A plus X. Now we're going to plug in point A. So what is our point A? Our Y in point A is 1, and then the X is 1. So we're going to put in 1 and 1. So we're going to have 1 is equal to A plus 1. And it means that 1 minus 1, because this is going to go to this side. And once it's crossing this equal to sign, the sign here will change to negative. So it becomes 1 minus 1 is equal to A. 0 is equal to A. So therefore, our A is 0. Once we have our A to be 0, the equation changes. Now we have Y. It means our Y is equal to the A. which is 0, plus our b, which is 1x. Therefore, y is equal to what? X. Y is equal to x. Y is equal to x. So that's the equation, the linear equation that we have solved. Y is equal to what? X. It means that the a is 0, and then our coefficient of x is 1. All right. I hope this helps. I hope this helps. So if you haven't subscribed yet to our channel, I would like you to do that. Do us a favor by subscribing, and liking this video and sharing. I will come to you another time. Take care and bye.